Hi, welcome to Teardown Tuesday. Yes, I couldn't even be bothered putting my ugly head on camera. Let's jump straight into it. It's a leftover mailbag item from several weeks back. It's the JVC EEVblog low-end, very low-end consumer camcorder. What is it? It's the model number GZHM300 SE, and it comes from a viewer called Mr. Z. He wanted to remain anonymous, otherwise his parents are very cruel indeed, and it's had a little accident with gravity there, so yeah, oops, but it does actually still work. Ta-da! It's going to power on. There it is, and we do actually get an image out of the thing eventually, so there we go. Let's have a look. Yeah, we zoom right in. There we go. There's my other camcorder right there. And we'll be able to compare the two. Here we go. This is my B-roll camera, as it's called. My second camera here in the lab. It's the Canon Legria HFM 400. It's got the same HD CMOS Pro sensor as what I'm shooting with here. This little camera, which is the Canon HF G10, which is bigger than this one. Again, so you can really see the compact size of this little JVC. Absolutely tiny. So let's crack this sucker open. I think we might need the set of jeweler's screwdrivers for this one. And I had a bitch about this in the mailbag. Look at this non-standard pain in the ass son of a bitch power connector that some dickhead at JVC marketing department thought that they were designed into this thing. Ugh! Should be hung, drawn and quartered, the bastards. Unbelievable. So anyway, how do we get into this sucker? I think looks like they look like little oh no, they're Phillips. Yep, they are Phillips screws. We should be able to get in there. There's a couple of screws on the bottom. I don't know, I've never taken apart one of these camcorders before really, so let's rip it open, and I expect to see inside here the sensor is going to be like right back in here, because most of these things are taken up with the zoom range. I mean, this has got a 20 times optical zoom, so in fact if we power it on, you can probably see the there we go, we can see the lens actually move all the way back right into that, so that's going to have quite a significant range of movement inside there. So I expect the sensor to be back here somewhere on these things. That's what most of the length in these are taken up for. So yeah, let's whip the screws open and see what technology's inside here. I think it's only like a year or two old, so it's pretty modern. I'd expect lots of lots of high level of system on chip integration and stuff like that. Of course, built down to an absolute price. I mean, this is, you know, a bottom of the range consumer camera, a couple $100 worth at best or something like that. So be interesting to see what makes this tick. Although, look at that, isn't that advanced? Dual SD card slots. Whoa, that's something that my only my Pro Canon cameras have got. Whoa, why bother? Yeah, dual memory, there it is. Should have read that. Oh, let's go. So this is a size 0 Phillips I've got here, and don't know how many screws we're going to need, but it's going to be quite a few. No doubt there'll be a hidden bastard somewhere, which will stop me from really getting the whole thing apart first go. So but the design of these, like the 3D, just the, you know, the 3D, designing the cases and all this in 3D and the housings and how it all fits together and the integration of the electronics just really highlights the need for, you know, cross-design team and cross-discipline work in the, you know, in designing a consumer product like this. I mean, I've been involved in many cross-discipline design teams that involve, you know, electronics designers like me, mechanical designers, production designers, and you know, even graphic artists would have been involved in this, user interface designers, all sorts of weird and wonderful and wacky people have gone into this. I'd love to know the design, the size and makeup of a design team for a consumer product in a company like JVC. If anyone does work in such a consumer electronics design team, please give us the lowdown. Oh, I got a couple of different. That was like a different size screw down in there. That bottom one. Who cares? I'm not putting this thing back together, so I don't really care about keeping tabs of where they came from. But yeah, if anyone works at a large consumer electronics company on like this, on these sort of things, then please give us the lowdown on what the makeup of a typical design team, because I find that sort of aspect of engineering quite fascinating, really. So it's one of the more fun things. Well, one of the more satisfying things that I've done in my career is work with lots of work across disciplines on a project that has, there'll be optical people, of course, working on this thing's optical specialists. Who knows, they might have even farmed out the optics to, well, that's a Konica Minolta lens, actually. I'm not sure of the association with JVC and Konica Minolta. They probably, JVC might own them or something like that. I don't know, haven't looked. I'm just talking out my ass here. But yeah, there's lots of, oh, there we go. Something's happening there. Lots of cross-disciplined stuff happening here. Let's get that strap off. And probably custom ASIC in this, or ASIC or two, probably shared across multiple lines, like, for instance, they do in the Canon, for example. The famous would be the Digic processors and stuff like that. They use the same processor. They develop that one ASIC and then use it across multiple camera lines, for example, in terms of like the still camera lines I'm talking about. Oh, there we go. See, we've got a piece came off. See, somebody had to design that. They had to get all that right, 3D model that and everything, put it all in place, make sure it all works, and get that and do this within like the typical 9-month development cycle time of something like this. Absolutely incredible. We can see the flex going in there. It's obviously a serial interface going over to this screen, of course. You wouldn't be able to have a huge parallel interface going over, so it looks like they've probably just got single power there, like 3.3 or 5 volts, and then just a couple of serial lines going across to drive that LCD. So it looks like we've got quite a few more screws as we get through the case of this thing. So I will, I think, stop the camera and try and prise this off. Here we go. It looks like this top piece is going to sort of yeah, there we go, lever off. Just plastic retaining clips and all that. Of course, nothing special with this cheap and with this plastic, just really flimsy, cheap ass consumer stuff. It's it's probably not a high quality impact resistant polymer or something like that, and it doesn't look like to be shielded or anything like that. And oh, bingo! We start getting all the exposed parts, and there you go. We can start seeing the main flat board down in there. We're going to get lots of flat flex. Of course, oh no, there could be some, look at that, we've got some shielding tape, some copper tape coming across here, which is screwed into that, what looks like that plastic there, and so possibly that goes off to another metal shielded thing, so the plastics haven't got any shielding in them, RFI shielding. But yeah, we have the one board with what looks like a test connector down in there. There we go. Who knows what that's for? That didn't attach to, this just sits on top like that. Oh, like that. So obviously that's not connected to anything. Test/programming connector. Looks like there's a header for another connector down on there. They haven't populated that. We're going to see lots of flat flex, of course. This flat flex here is just for, looks like the snapshot button and the zoom control up there. That's about it, nothing fancy. We've got another flat flex going off here to something up the top here. Is that possibly the well, no, that's like an infrared cover, so that could be like an infrared receiver or something like that. Yeah, that would be my guess, is that is an infrared receiver down in there. I could get out the zoom lens and take a look at that. And there we go, that's that flat flex cable up front, 2-pin part there. Yeah, it looks like a photo diode, photo transistor there. There's only the 2 leads going off there down to the board. So, you know, look, they've gone to the effort. You've got to design, you know, somebody had to design all this flat flex cable, and that would be a separate soldering production process just for that. And then you've got the mounting, plastic mounting bracket here. All of this has to be designed. It's incredibly complex. I'm trying to lift the lever the front lens cover off, and that's, you know, everything is a separate part. Absolutely incredible. You know, you think they could have maybe just mounted it on the side of the board there and just shifted the window over a bit. You know, instead of having like the window here, they could have, you know, put the window on the side here, but then it wouldn't have been, you know, nice and sexy and symmetrical looking, you know, down the center line of the thing. So, but that would have saved, you know, designing the mounting bracket and the flat flex and the separate assembly process and all that by just, you know, side mounting that vertically on that board as part of your assembly process for that board. So, you know, decisions like that may have been driven by the, you know, the engineers may not have had a choice. It may have, you know, the concept, the artist who, you know, the industrial designer or something came up with the concept. Oh yeah, here's our infrared window here. It looks beautiful. It's in the center line like this. And, you know, tough titties to the actual designers. They've got to go in there and, you know, be able to mount that there when they know that their board's over here, and they go, oh, bummer. They get to that point in the design process where they just, you know, oh shit, our board's over here, but everyone, the decision's been made to put our window here. We have to design all that in. Oh, blah, blah, blah. Ah, man. Sometimes your hands are just tired in the design process. And the same things happen with this microphone board. I've taken the front connector off, and you can see the grills for the mics down here. Obviously, stereo mics. They've got 2 of them, or they, you know, or they appear to have 2 of them anyway. And those mics are on their own flat flex board. Let's take that out. They've got little, hey, they've put that on a rubber mount, a rubber surround to isolate handling noise. So that's actually pretty good on a low-end consumer one like this. That's not bad at all. They've isolated those in their own little rubber shock mount. Look at that. Rather neat. I like that. That is, and they do actually have dual electric mic inserts there, and bingo, off they go on their own flat flex and everything else. And you know, they've done that because they have the rubber little isolated shock mount there, and that's rather good. You know, a bit of thought's gone into that. They haven't, this one isn't really one of those one hung low cheapies. Not really surprising considering it's JVC, even one of their bottom of the range cameras. And you'll note the little stiffening, little clear fiberglass type stiffening plate they've glued on the back of that flat flex cable there, just to give the rigidity in that. I mean, there's quite a bit of flex. That's actually probably less flexible than an equivalent like a 0.8 millimeter fiberglass board, or for that sort of length. But yeah, nice little touch there. So let's take this side cover here off. Looks like there's 2 extra screws in here, and that should, ta-da! And check this plate out here. They've designed in this separate plate, mounted in with a separate screw. It's going to have its own moulding, its own assembly step, and the sole purpose of that is the retaining hook, that black retaining hook, for that. I mean, you know, what, they couldn't put that into the case? Or I mean, maybe this outer case, a totally different type of plastic, and was going to, you know, wouldn't have done the business, so they had to use maybe this plastic in here. I'm not sure what type it is. Got a number 2 on there, whatever that means. If you know your plastics, that might actually... No, here we go. This is a PC ABS plastic. So, yeah, I don't know. All that effort just to put in a little retaining clip. And they've done it over here for something else. Complete separate moulding process just to retain that door. Man, why? And that board has nothing but the dual SD card slots, a couple of little bypass caps on there. That's about it. You've got to have that. But yeah, it's its own assembly, and then a flat flex ribbon going over to the main board. So it looks like we just have the one. We're going to have just the one main processor board in here. We're going to have the optics in the center here, and really, well, there's going to be a sensor board at the back. I can see a board in there. It's going to have the battery contacts as well. I'm not sure if it's got the sensor on it, but maybe the sensor's inside, more likely inside, connected via another flat flex ribbon or something like that. Can see some more ribbons down in there. So let's whip this board off. We're getting closer and closer to the main board. And of course, there's probably little to no thought put into the servicing of these things. I mean, these are throwaway consumer item cameras. No, there we go. That's a dual-sided load there. Well, they had to do the dual-sided load anyway. I was going to say, why bother putting the caps on that side there when everything's, when you had to put components on the back. They've got some termination resistors on there. I won't bother zooming into that. A couple of unpopulated parts and a few other bypass caps, and that's had its own testing or something done. There's a mark on there, and what is that? That's some sort of, is that a lever contact switch? That's probably the door close. No, it's not the door close switch. What is that? That is a, looks like a grounding contact over to this. Yet another flat flex just dedicated to the record button there. They love their flat flex stuff, but really, I mean, it's the only viable way to design consumer products like this into a certain usable form factor. They've been doing this since, like I remember, you know, the Polaroid instant cameras back in the late 70s, early 80s, or whatever. They had use of flat flex technology in very early, regular film cameras that might have had some electronics in them, small amount, or flat flex, designed to enable these consumer form factors. We've got ourselves some RFI shielding foam there just to join this metal piece down in here with something on the side of the case. And that's the top zoom mechanism there. It's got its own the own assembly mount, goes off to the ribbon over here, and that's all integrated into one, the zoom and the snapshot and the record button. That'd be all the one solid piece of flat flex, no pun in solid, yeah, one flat piece of flat flex. And we can see some multi-way ribbon going down in there. That's probably the sensor, although there's another one down there, so yeah, it's in there somewhere. And we've got ourselves a couple of light pipes there, which just mate up with surface mount LED down on the board down in there. Nice. So they haven't had to wire that over on a separate flat flex. Very common to get these sort of light pipes. So you can mount your LED cheaply on your board right back out there and then direct the light out anywhere you want. And looks like this whole side panel pulls away, and ta-da! There is our main board with a flat flex joining the two. Couple of little tiny BGAs on there we'll take a look at up close. There's some flat flex going behind there for some of the joining some of the optics down in here. There's some sort of sensor down there. There's a sensor at the front there. That comes apart really quite easily. I rather like that, but I mean, this could be a double-sided load there. We're not sure. We'll have to take that board out, but not a huge amount on there, really. I was expecting a much larger BGA device than what's on there, so I can't see a larger BGA device on the bottom because there's no telltale like bypass caps on this side of the board or anything like that. Someone's had a little go on there with the old texter. There's the backup battery down in there. soldered onto the board, not user replaceable, all part of the consumerism of this. But that's actually a lot thinner than I thought, that optical mechanism in there. But there you go. I mean, the sensor's likely on, you know, way back here like this, and all of that is your lens in and zoom in system. So this is probably, oh sorry, yeah, not a sensor, this is probably like your zoom motor or something like that. So zoom motor, and what is there, an iris motor in these sorts of cameras or something to that effect. So let's whip that apart further. And I was right, there is a bigger, huge JVC custom part down there. That's their, yeah, we'll have a look at that, but that's their, you know, got all their whiz-bang technology in it, and it is a BGA. So on the flip side, I just thought that I'd see some more, you know, an array of bypass caps or something like that on there, but obviously, you know, maybe a little core power supply there or something like that. There's a big inductor there, probably for one of the core voltages or something like that. But there you go, there's all the main chipset. Down in there we've got ourselves the speaker, and that is about all she wrote. I've got to get that pain in the ice off, but you can see the complexity in the construction in these. It's absolutely incredible. I'm always amazed when I take apart consumer items that are that really have dense packaging like this. I'm just always amazed at the construction, the complexity in construction which goes into these things. There we go, bingo, that pops off there. Got ourselves a little speaker connector there, ta-da, it's out. There we go. There you go, if that means anything to anyone. Dacell polymer, haven't googled that. Novalloy, is that the type of polymer plastic used in the hinge, or you know, the mounting for the LCD hinge there? I don't know. And both our HDMI and component inputs all go via this flat flex cable over to the main board there, so they're not mounted on the main board at all. And you'll notice that the buttons on the side here actually aren't just loose buttons going down the switches. They've actually got a little spring, plastic spring bar in there just to give them a bit more tactile feel, I guess. And there's the tact switches, right angle on the side of the board like that. So they could have just got away with like loose caps, but yeah, they decided for that single molded retention system. So I guess that kind of thing just makes it less fiddly, you know, when you're assembling these things. The operator who's assembling this doesn't have to dick around with, you know, 4 separate little buttons there, getting them around the right way and all sorts of stuff. They just drop in a much easier to handle single molded plastic insert like that. And there's the battery board. It's got the USB interface as well, the power, that custom pain in the ass power connector up there, the battery connector, that's just surface mounted on there. That's going to be the lithium ion battery charger. Not even going to bother decoding the part number on that thing. Rear PCB assembly Y. And on the other side, then we've got the tact switches as we saw for those side buttons. We've got the headphone jack. I don't think this has an external microphone input, and not much else. Look at that, they've gone to the effort there to mount that LED just on a slight, you know, 10-15 degree angle from the vertical like that, just because, I don't know, that's the, you know, the light pipe sort of, you know, had to fit in there, and all that sort of stuff. So, you know, the person who was laying out this board had to talk to the industrial designer of the light pipe and the case and the all sorts of things. It's just, you know, a lot of effort, you'd be surprised, goes into just selecting the angle of that LED on the PCB layout. Lots of flow-on effects from somebody deciding up, you know, the food chain or across the food chain, deciding that they want the LED in a particular spot on the case. Flows right down to the poor PCB layout person. And there's the main custom ASIC. It's the HT Gigabrid, not Gigabird, Gigabrid, whatever that means. It's the Premium 2 chipset. That's what this camcorder is advertised as having, and that does all the image processing and all the fancy stuff. totally custom ASIC developed by JVC, presumably. Just like, you know, all the major manufacturers, Canon and everyone else, design their own custom chipsets. And they, you know, try and compete against each other. Oh, we've got the new Series 3 of the, you know, the Digic chipset or whatever, or the Gigabrid. You know, who knows? The latest JVC cameras probably have the Gigabrid Premium 4 or something like that. Ugh, who knows? I don't keep up. So an absolute metric buttload of engineering, R&D and money goes into designing these chipsets. So they want to use them across as many models as possible. So this same chipset is probably, you know, hugely over-engineered for this base model, you know, $200 entry-level camcorder. It's probably used in, well, was used back in 2010 when this thing was released back in there. High-end models as well, so probably much more capable and has features that are not enabled in this particular model camcorder. And there's a Sony CX-M3017, and a quick Google of that didn't give me the data sheet, but it got me another data sheet for some LCD panels, or an application sort of note, which shows that this is a single chip LCD panel driver, and no surprises considering that the LCD connector is smack on the back there. So that's what's driving our panel via that flat flex cable there, and as you can see, the flat flex cable is very dense down in there. The trace pitch in there very dense, and it goes to a widens out to a wider pitch flat flex connector. And there you have it. There's a little bit of an app note there showing the single chip driver CMX3017 in the middle. It just takes the sync signals and the RGB YUV signals and the serial data and just drives the panel directly. So clearly this chipset is only designed for like these low-end LCD panels, you know, 123K dot or 200K dot panels, which you get on the very low-end cheap-ass camcorders. I mean, what I'm filming with at the moment, the Canon HF G10, it's got near 1 million dots on it, so, you know, quite a high-resolution screen, so would be using a much higher-end chipset. And here's the Texas Instruments THS 8136, and that's a video DAC. So what they're doing is the processor down in here is, you know, it's getting all the stuff digital from the sensor, then it's using the video DAC down in here to generate an analog RGB type signal, which then goes into the panel, Sony panel chip over here we saw, and drives the panel. So they go from digital from the sensor back into old school analog, and then to drive this chipset over here. You know, it seems crazy, but obviously they've decided, well, that was the, you know, the cheapest, best solution available for driving that LCD panel. I mean, this chipset, in theory, they could have integrated this ASIC, if they were smart, could have integrated the driver directly for the LCD panel in it, or used another LCD panel, which was just driven by the digital direct, you know, serial or parallel data out from here. Could have, you know, gone into some direct digital panel driver instead of converting it to analog, old school analog signal. But and we've got ourselves a little tactile lever switch there, which obviously is designed to detect something, whether or not it's like a case open or something like that. I'm not sure. I've taken all the bits apart. I'm not actually sure what was making contact and making contact there now. And we could go into detail on all the other parts on here. There's a little BGA down in there. This is probably some sort of RTC or something like that, because that looks like possibly a 32 kilohertz crystal there, perhaps, although it could be higher. Who knows what these are doing? I could, in fact, AK, that seems like audio. I can look that one up. AK 4694. Nope, I got absolutely zip on that one, folks, and I don't know what that text to scroll in there means. Your guess is as good as mine. And yeah, by all means, go look these up, but nothing terribly exciting to write home about. And we've just got more power stuff around here. You can tell by all the large traces. Large inductors are always a dead giveaway. Some sort of, you know, some sort of regulator in there, low dropout regulator perhaps. No, we're getting into the obscure numbers down here. And there's curiously a lot of passive parts around here. Look at all these resistors. So I'm not sure what that puppy's doing there at all. Now folks, as predicted, the sensor was all the way back. Right at the end here. Of course, they're going to maximize all that for the optical, all that distance there for the optical zoom. The sensor is on this board. Dead giveaway, you can see some BGA balls, or you can see something down in there, which is going right in the center line. That's obviously going to be the surface mount sensor on the bottom there. And it's all rather complex how this comes apart. Look at all that complex mold in there, which goes over all that with all the cutouts for all the flat flexes. I would hate to have been the system design engineer on something like this. Absolutely terrible, but there you go. We're getting down into the main sensor now and the optics. And here we go, folks. We have ourselves the sensor on the back here. Is that a I'm going to presume that looks like a heat sink, like a heat spreading plate acting as a heat sink. You can tell by the sensors obviously under there, like a BGA sensor or a reverse mount sensor. It might have a hole in the, well, it's got to have a hole in the front side of the board. Actually, if it's mounted on this side of the board, there'll be a square cutout in the front of that board, and the sensor will be mounted on the back like that. And this is obviously attached to the back of the die on that thing, and just spreading the heat out, because these things do operate quite quick, and they do pump out a lot of data. So this sucker is clearly designed to minimize the heat on that. Oh no, there we go. I was wrong. It's there. It is probably a BGA mount sensor on the front. They've got a thermal pad exposed there, and the heats, and of course that just acts as a heatsink. So it's still acting as a heatsink, but the chip is actually mounted on the front. And if we zoom right into that, we'll be able to see some micro vias on there. Let's have a look. And there you go. Look at those little micro vias in there, designed to get the heat from one side of the board to the other. Tiny little things, 0.1 millimeters or something like that. If we take that backing plate off, we should be able to see the sensor. Ta-da! There it is, folks. So there's the arse end of the lens down there, and that just sits over the sensor plate in the back. Simple. And there's our die. Check it out. You can see the gold bond wires going right over. This is using my ×10 macro lens, by the way. If people are wondering how I shoot this, I'm using an Opteka high definition ×10 macro lens on my Canon camera. And for the close-up shots, I just screw that in, and we can see our die in there beautifully. So yeah, I'm assuming that's like a CMOS sensor. It probably says so in the specs. Haven't checked. And that board's actually gunked down in there. You can see the gunk down there. There you go. Someone's gone around with the hot snot and actually embedded that in there. But that looks like a leadless chip carrier. It's not actually a BGA one. You can see the pins on the outside of that. Fairly typical. It's not a huge pin count device, as you can see by number of the traces coming here. It's basically serial data coming out of this thing, I believe, or it could be it could be like 8-bit parallel or something like that. Not entirely sure, but yeah, that one is gunked in there. I won't even bother taking that out. There's nothing interesting to see on there. It's just a sensor. And we can see one of the motors down in there, maybe the iris motor, and the one up there, probably the zoom motor, all connected via that flat flex. And they've got something else over here, which I don't think is another, well, it might be another motor, I don't know. If we take the side plate off there, ta-da, we can see inside the lens mechanism beautifully. Look at that. They've got the fixed lens on the front, which has had a issue with gravity there. We've got another lens in there which moves. So obviously those two motors, all they do, there's no like iris motor or, you know, anything like that. It's not like it's, I would have expected, actually. Where is the iris? I don't think it has one. No? Anyway, I don't know. I'm not a huge camera buff fan and how all these optics work, but clearly we've got two movable lenses here, a fixed one in the, well, fixed one at the front, fixed one in the center, and then two movable lenses here, which are must be controlled by those two separate motors. So I'm not entirely sure, like, you know, one's going to be the zoom, like that's going to be the zoom there. I probably shouldn't be doing that, ratcheting that up and down. There's a little worm screw down in there, right, that's driven directly from the motor. There'll be one down here as well. So one's going to be, well, you know, a combination of these works on the zoom and the focus. So that's probably, you know, I'd say, you know, that's the zoom mechanism and that's the focus mechanism. But like I said, I don't know a huge amount about these types of optics. So combination of them are going to work. So maybe we can actually, with the camcorder here, we can actually look through this and see if we can actually focus on something. Give it a go anyway. And here it is. Check it out, folks. I've got my second camera set up here, and I've got the target PCB over here, which is the PCB from the camera, and you can see that using my ×10 macro lens here, I'm able to get an image focus quite nicely through that. Now if I adjust the rear one, that has some zoom capability, but that's also focusing, and the front one here, that really has a huge difference. Check that out. So it's a combination of the two of them there that gives us that image. Look at that. And that's even through the distorted, well, the cracked lens and everything else. Not bad at all. And if I move the forward lens, it's all the way back at the moment. So if I move the forward lens forward a bit, watch this. We'll be able to then focus on our lens. There's our lens. There's our cracked and chipped lens on the front of this thing. Not a problem at all. So you could go into all your optical theory and all that of exactly what lenses I've got, what focal lengths and everything else I've got here, and all that sort of stuff. But that is pretty neat. I can then focus on that front lens. Look at that. I love it. Nice. So it would be possible to sort of hack one of these zoom lenses from a camcorder onto an existing sensor, any sort of, probably any sensor you wanted, really, because if it was, if the sensor was flat on the back of it, like this, just like the sensor was for in the actual original unit itself, then not a problem. You could use these lenses provided you get all the focal lengths and everything else right. And that other thing down here, I was right, it is a sensor. There we go, we've just got a photo sensor down in there, probably to detect the end of the zoom range. So these are actually very simple systems. Really, when it comes down to it, just two movable lenses in there and two fixed lenses, and that's it. And that screen is just held in place by a couple of screws there and there, and under a removable cover on the end there, and it should just unclip somehow. And that really was quite aggressively clipped into there, but we can see we have our LCD panel. There's not much on the back of that. Here's a touchscreen, a capacitive touch controller, which goes through that flat flex up to the board on the front here, which then has all these capacitive touch switches and a capacitive slider. And yes, folks, marketing have got a hold of this. It's laser touch operation. And as you move your finger, it's got LEDs that light up that whole strip like that. what a wank. And that board is actually adhesived down on there. Real pain. So we'll rip that out and ta-da! There we go. Well, the LEDs actually were shining through somewhere else. They're not actually on this board. They just shine through these slots, and there's only 4 levels there, really. But there is the capacitive pads on these things. There's the capacitive touch pad, so there's only 4 pads there, so you slide your finger along like that, and they're your capacitive touch buttons. And the controller there, no surprises, Cypress, one of the big players in the touch market. It's a CY5C, it's a 2324 CapSense PSOC controller. And once again, someone at the factory has written some stuff on here, presumably after testing. So that, folks, is all that is left of our poor camcorder. I hope you found that interesting. I always find these consumer items fascinating, as I talked about earlier in the video, just from a design point of view, and the systems engineering team that goes into making all of these 3D molds and designing the whole system integration. And you got your lens optics people, and you got your ASIC people who designed the processing ASIC, and you've got you know, you've got your marketing people with your laser bloody touch system and everything else, and they are really extraordinarily complex bits of kit, really. And it's amazing that they can sell these for, like, you know, $200 retail. I mean, you know, the retailer's getting, you know, 40% of that or something, and then the wholesaler, and the, you know, these are popping out of the factory at, you know, well under $100, you know. So I don't know what sort of volume they have to you know, do up, and they have to commit to up front to, you know, get these to meet these sort of, you know, really demanding consumer price points. Maybe the margins on these are a lot lower than a lot of other items, perhaps. But, you know, look, you know, if I was designing a product and I went, I've got to mold this into it, and I've got to do all these flexes, you know, there's like half a dozen at least, or a dozen little flat flex cables and assemblies and everything else just inside a simple camcorder like this. It's just crazy. I would, you know, I'd blow my R&D budget just, you know, getting somebody to spec assembling and building that bloody thing. It's crazy. I don't know, because I've been, that's the difference between the consumer electronics design industry and the industrial one, which I've primarily been involved in all of my career, essentially. I've never worked on consumer items like this before. Yeah, I've done volumes in the hundreds, a couple of 100,000 for a particular board or something like that. So almost sort of, you know, almost getting up to that really consumer level volume. But it's just, it's a different ball game to, you know, shaving off every cent and being a massive corporation like JVC, who commit to and churn out these designs, and they design so many models of them. It's just incredible. So there you go. I hope you found that fascinating. I certainly did. So thank you, Mr. Z, for sending that one into the mailbag. And if you want to discuss it, jump on over to the EEVblog forum. That is the best place to hang out and do it. And if you like Teardown Tuesday, please give it a big thumbs up. Catch you next time.